Alright, this video is going to introduce us and get us started with problem 1.3 in the Moving Straight Ahead unit, which is all about raising money in the context of using linear relationships. Our essential question for this lesson is, how does the starting value impact the table, graph, and equation that represents the relationship? Through this video, you're going to get started on the first part of the lesson. That way we can spend our class time having a discussion about this and making sure that we understand this LEQ completely. So before I move on, let's review linear versus proportional, something we've been talking about but haven't formally defined in any of our instructional videos. We should know by now, but linear data is simply data that has a constant rate of change. That's the only requirement that's needed. And we know that if it has a constant rate of change, it's a straight line. So any graph that is a straight line is linear. Now, we can add a requirement to that, and this is what we talked about first, was something being proportional, meaning that the data has a constant rate of change and it has a starting value of 0. We would call that data proportional. So notice that the definition here got a little bit shorter, a little bit simpler. Proportional data is linear and has a starting value of 0, because linear means to have a constant rate of change. So remember, anything with a straight line is linear. If the starting value is 0, it's proportional. So I'd like you to take a second to think about these 3 true or false questions. Maybe you want to jot them down in your notes, but you're going to answer or respond to these in the Edpuzzle with true or false, and then move on to check your answers. The first one, true or false, all linear data is proportional. That is a false statement. Linear data can have a non-zero starting value, which would make it not proportional. So we can have a straight line graph that doesn't go through the origin. Number 2, all proportional data is linear. That one's true. By the definition of proportional, it has to be linear. So if it's proportional, it's always linear. That's true. So you can see that we can work, get more specific. All proportional is linear, but not all linear is proportional. Number 3, data must be either linear or proportional. This again is a false statement, because both linear and proportional require that a set of data to have a constant rate of change. If a data doesn't have either, or if it doesn't have a constant rate of change, it can't be either linear or proportional. All right, let's get into problem 1.3. Here's the situation. We talked earlier about Mrs. Chang's class holding the walkathon, and we went out and found our walking rates so we could determine how far we might need to walk in order to raise so much money. So in the walkathon, each person finds sponsors to pledge a certain amount of money for each kilometer they walk. The students in Ms. Chang's class are trying to estimate how much money they might be able to raise. So that's what we're going to look at through this problem. So some things that I'd like you to keep in mind as we go through this problem. What variables affect the amount of money that's collected? How can you use these variables to estimate the amount of money each student will collect? And will the amount of money collected be the same for each walker? So take a couple seconds right now, maybe pause the video, write some answers to those questions, and keep those in the back of your mind as we move through the video. All right, so each student found a sponsor that's willing to pledge money to them according to the following description. So we call these the pledge plans. So these are the rules or the plans that the walkers have to follow in order to raise their money. Leanne's sponsors are going to donate $10 regardless of how far she walks. So if she walks 1 kilometer, she's getting $10. If she walks 20 kilometers, she's getting $10. Gilberto's sponsors are going to donate $2 per kilometer he walks. Elena's sponsors are going to make a $5 donation, and they're also going to pay her 50 cents per kilometer she walks. As you think about these 3 pledge plans, they all have the same dependent and independent variable. I'd like you to identify those, put your answers into the Edpuzzle, and then continue on. So in this case, the independent variable is going to be the distance walked, and the dependent variable is going to be the money raised. Okay, so the amount of money they raise depends on the distance they walk. Okay, it might not seem like this in Leanne's case, but we're going to see how this applies in just a couple minutes. So here again is an overview of the pledge plans, and this is going to wrap up our video with the assignment that I'm asking you to complete now. There are 4 things I'm asking you to do to be prepared for our next class. Number 1 is to make a table for each student's pledge plan that shows the amount that each sponsor will give to them if they walk 0 to 6 kilometers. I've put an example of what this table should look like on the slide. So the best thing for you to do is copy the table and fill in the data using the information from the pledge plans. After you've made the table, you need to graph the 3 pledge plans on the same coordinate axes. And I would suggest that you use a different color or highlight each of them in a different color. I would graph them in pencil first to make sure you don't make any mistakes. Remember, everything we're dealing with in this class is linear. So if you graph something that isn't a straight line, you are incorrect. We graphed back a couple videos ago. If you don't remember the important things that we need to have in graphs, I suggest you to take a look at your notes or go back and find a previous video. After you've made the table and graphed, you're going to write an equation to represent the relationships between the distance walked, you're going to use little d for that, and the amount of money donated, you're going to use a capital A for that. So each equation should have those 2 variables and some numbers in them. Lastly, you're going to identify each set of data as linear, proportional, as neither, using the most appropriate and most specific term. So if you come up with something that has a crock and starts at 0, don't check linear, check proportional, because that's the most specific term. In addition to writing the answers as linear or proportional on your paper, I'd like you also to submit those to the Edpuzzle. Once you're done with those 4 things, you're ready for our next class. Make sure you have them all done before you come in.